the video 6 from my course on machine learning. And this is about exploratory data analysis and data visualization. This is brought to you by my YouTube channel AINEXUS in the playlist course on ML. So, first let's look at what are the learning objectives. It explains exploratory data analysis, which is called EDA for short, identifies data quality issues, performs univariate and multivariate analysis. We'll understand what that is, and select suitable visualization, what visualizations for what, and derive insights for machine learning. So, data pre-processing, we have already seen the previous video. Let us first find out the difference between data processing and exploratory data analysis. So data pre-processing is fixing and preparing the data. So we clean and transform it so that a machine learning model can use it. Okay, EDA, or as we call exploratory data analysis, it investigates the data. What does the data actually look like? What problems or patterns does it have? So if you look at a workflow, if you take data, the raw data, you have to first do data pre-processing, then you have to clean the data, then you have to do EDA and visualization, and finally machine learning. So what is exploratory data analysis? It is the process of exploring and summarizing a data set using both statistics and visualization to understand its characteristics before we build the machine learning models, so that you get the good machine learning model that suits the data. So objectives of exploratory data analysis is understanding the clean data, understanding the data distribution, discovering patterns and trends, analyzing relationship between variables, visualizing data for better insights, generating some hypothesis from that, discovering any anomalies, and this helps you to select and support better machine learning models. So actually EDA answers the following questions. What does the data look like? Is it clean? Is it suitable for machine learning? So the types of EDA, so univariate analysis is studying of one variable at a time. So example is age distribution, salary distribution, product categories, and so on. The visualization, which we will discuss in detail later on, used for this type of analysis is histograms, box plot, density plot, and bar chart. Applications include finding distribution, finding skewness, and finding outliers. Then comes bivariate analysis. This is studying the relationship between two variables. Example is age versus salary, hour study versus marks. Visualization used here includes scatter plot, line chart, grouped box plot, and correlation matrix. Application includes correlation, that is measuring the strength and direction between variables, identifying patterns and trends over time, and understanding how one variable depends on it. And then comes multivariate analysis. This is studies relation among three or more variables. Example, age, income, and spending score. And methods include pair plot, heat map, PC visualization, parallel coordinates. We'll be talking mostly only about heat map in this video. Application include finding feature relationship, clusters, and redundancy. Then we go to summary statistics that is used in EDA. This is the usual statistics that we know, so I'm not going to explain it. Mean, median, mode, minimum, maximum, standard deviation, and quartiles. This is also importantly used. So example data set, let's take this, and you have the summary statistics. You find the mean, you find the median, and then you find here there's no question of mode, minimum, maximum, standard deviation, and the quartiles. Okay, so this is given here. And Python provides through pandas, it provides how to find the mean, how to find the median, and so on. So these statistics help summarize numerical data before you do the actual visualization. So let's go to data visualization now. It is a graphical representation of data that helps identify patterns, trends, and relationships quickly. Just looking at that graphical, representation you can find out. So it simplifies complex data, it detects trends, it identifies outliers, it compares groups, and much more importantly, it helps to communicate the findings effectively, which is even more important in business communication. Let us look at 7 examples of data visualization. First, you have histogram. That is the distribution of numerical data. Here it shows the distribution of exam scores. Next is bar chart. It compares values across categories. In this example, sales for each product category. Line chart displays trends over time. Here it's showing the website visitors over time. Then you have scatter plot. It shows relationship between two variables. Here it's between height and weight. Then you have the box plot. Here it detects outliers and summarizes distribution. Test score by class in this example. And a very important visualization is the heat map. It displays correlation between variables, more than two variables. So here it shows, if you take the first row, it shows a correlation between sales, between marketing, expenses, profit, and customer satisfaction. We'll go a little more into correlation later. So here you have the pie chart, which shows proportions of a whole. In this case, market share by a particular brands. So next you have popular Python libraries that we must know. Pandas, it is a powerful library for data manipulation and analysis. NumPy is a fundamental package for numerical computing in Python. Matplotlib is ideal for basic plots. Plotly, it creates interactive data visualization with features like zooming, hovering, and panning. It's easy to use interface. Then you have Seaborn for creating attractive statistical data visualization, which is actually built on top of Matplotlib, and it's suitable for web application. Then you have scikit-learn, simple and efficient tools for machine learning, which you've already seen in the Python video. So typically, you read the data from various sources, you explore it, understand the data using summary statistics and EDA, create meaningful visualization to discover patterns and insights, then handle missing values, remove outliers, and transform the data, and finally, you build and evaluate machine learning models. So next we'll look a little bit into correlation analysis. So what is correlation? Correlation measures the strength and direction of the relation between two numerical variables. So correlation coefficient ranges from +1, strong positive correlation, 0 no correlation, -1 strong negative correlation. Actually, we've discussed correlation when in a video on maths when we were talking. And so here is a common visualization about correlation. One is a heat map. It displays correlation coefficient between variables. So it gives the actual value. And then you have the scatter plot. This is only for two variables. And the application includes feature selection, removing redundancy, understanding dependencies, identifying strongly related features. So this is very important as far as machine learning is concerned. And let us now look at the best practices for data visualization. So choose the appropriate chart type, that you have to first do. Add clear titles and axis labels. Use consistent scales and colors. Avoid clutter and unnecessary effects. Highlight the important insights. Keep visualization simple and easy to interpret. So the summary of this particular video is it explores and understands clean data. Summary statistics provide a quick overview. Visualization reveal distribution trends, relationships, and outliers. Matplotlib is ideal for basic plots. C is best for statistical visualization. Plotly creates interactive visualization. So finally, we have to conclude that a good EDA leads to better machine learning models. Now, these are the references, both online and offline. Then I've given you some short questions that you can answer to understand the topics, and also descriptive questions. I've given you some problems also. And then I've given you some mini projects customer shopping behavior analysis, and movie rating analysis. And finally, I would like a feedback from you. And the next video, video 7, is about supervised learning, linear regression we're going to talk about. So please do subscribe to my channel, AINEXUS. And the playlist you have to do inside that is the course on ML. Thank you.